So yeah, thanks very much for joining me. My name is Stephen Rennick. I'm the CEO and co-founder of Tilores. And as you will have all seen last week, probably via LinkedIn, we published a case study that we had done looking at the number of duplicates, duplicate director records that Companies House has. And basically, we found 10.1 million director records in Companies House. So in theory, there are 10.1 million company directors in the UK. And after deduplicating the entire database in Tilores, we found that actually there's about 9.5 million directors. So that means that Companies House does have quite a lot of duplicates. There's about 600,000 duplicate director profiles in there, which means there's a duplicate rate of about 6% in total. That might seem like a lot, and it is quite a lot for an official government database that should be considered a source of truth. But in the grand scheme of things, that's quite normal compared to what we see. Obviously, we work with a lot of companies that are looking to deduplicate data, and 6% is not great, but it's definitely far from the worst that we have ever seen. And why did we do this in the first place? The reason was that many years ago, I noticed that my own profile is in the Companies House registry multiple times. I've had a few companies registered to myself over the years in the UK, not for quite a few years, but until about 2017, I had at least one company in the UK. And what I had noticed was that every time I registered the company, my details were slightly different. And Companies House each time considered me to be a completely separate person. So you can see there's obviously more than one actual Stephen Rennick, but the three Dr. Stephen Rennicks are me. In one of them, or in two of them, I put my middle name. In one of them, I have not, and the addresses on them are different. I've always used a kind of correspondence service address rather than my personal address, but in most of these cases, it's been somewhere different. And as far as Companies House is concerned, those are completely separate records. So anybody that's ever registered more than one company, if they use any slightly different details, there's a pretty good chance that they have ended up with a duplicate record. Now, of course, that's not ideal if you're trying to do research on company directors, whether that's for due diligence for an investment or an acquisition or something. You want to look at a director's record and see all the total appointments that one director has. And if the data is spread out like this, then it is very difficult. And as it seems from when we published this last week, this struck quite a nerve, and a lot of people agree that this is problematic and annoying, and many other people had noticed this problem themselves. So we wanted to do this deduplication of the data, and before I jump into a bit more detail on that, just a little bit of terminology. We've called it deduplication of the data. This field of data science comes under lots of different names. We usually call it identity resolution, i.e. we are resolving data down to unique identities. Elsewhere, it might be called record linkage, entity resolution, fuzzy matching, or data dedupe. It all means the same thing, which is what we're about to look at. So at its heart, identity resolution is about revealing hidden relationships in data sets. So if you imagine you have hundreds or thousands or millions of customers or people or directors in a database, there is a very good chance that some of them are related to each other. Most of the time when we're doing identity resolution, we're doing it for financial services or e-commerce companies where they're having people signing up to their platform online, and they're wanting to see, okay, this person that's just signed up, are they truly a new user or a new customer, or are they actually related to previous customers, either because they have forgotten their details and just created a new account, or perhaps because they're creating multiple accounts in an attempt to defraud us, buy products with stolen credit cards, for example. And the way that we reveal these hidden connections, it comes down to three kind of broad categories of matching data. We're always working on record data. In the company's house case, the records were the company directors themselves. And usually we do three different things. We do string matching. String is just a fancy word for words. So it means looking at the words and seeing if they are similar to each other. It means geographical matching. So very often if you have address data and you actually encode that data with geographical coordinates, you might find that two records are associated with each other within 50 or 100 meters or something like that. It could be the address details a little bit messy. Using geographical matching, you can say if two records belong within a certain distance from each other, then they can be matched together. And we can also do temporal matching. That's matching based on time. That is not really relevant for the company's house use case. But if, for example, you're matching transactions in a ordering system, you might want to say that all of these transactions that were created within a certain time frame belong to each other and should be matched together. So broadly speaking, that's what you can do for the data, for the matching of record data. For this use case, it was mostly based on the string matching. So this little animation just kind of shows you very briefly the sort of thing that you'll look at when you're doing this deduplication. You can see Vincent van Gogh, quite a difficult name to spell. If he was actually written as Vince van Gogh with a different spelling of his surname, you could see that a human, you can see that that's probably the same data. The date of birth here, for example, that could be considered the temporal matching. Maybe the 3 and the 0 have just been reversed here, so they are correct to within the last month. And then you've got another kind of string-based matching here. You can see these two email addresses are very similar. If you were to strip out the numbers in the email address, you might consider this to be the same email address. That's a common attack pattern in e-commerce, that people will just add numbers to email addresses to create unique accounts, but they're actually somehow all related together. And then the trick is to merge these together into one so-called identity graph, so you know that all this data from the different customer records belongs together. Why is this difficult? This is a problem that on a small scale is not so difficult to deal with, but on a big scale is very difficult to deal with. And there are technologies out there that people try to use to deduplicate data, to do identity resolution. The problem is that they often work on batch data, which means that the databases are by definition always out of date, because as soon as you add a batch of data, then it will process that batch, but then as soon as the processing has started, that data set is therefore out of date. They get very slow. So as these records all get connected to each other, all the different director records or customer records, they get very slow to search the data because the connections are very complicated, and they're actually quite expensive to run. You need to have lots of servers and people to look after the servers to maintain them. So where we see people struggling with this, these are the main sorts of problems that they run into. And so obviously we come from a background of sorting this sort of data. Tilores is a real-time identity resolution technology that transforms data, deduplicates record data, and then links it together so that you have these complete identity graphs of data that can be searched in real time with no limits on the scalability. So what I want to do now is just jump into Tilores, show you briefly what the data looks like on our side. So you would have on the page on our website, which showed the company's house kind of showcase, you would have seen there was a search window there. That was like a public kind of representation of the data. It's using the same data set that I'm about to search here. So it is the kind of the live data, but this is Tilores itself. This is our tool. And all I want to do is show you one example of a person. So there's no suggestion that this person has done anything wrong or illegal or dodgy or anything like that. It's just a person who has a large number of duplicate records. And I've got her name here and her locality, which I will use for a search. And then I will look at what we call the graph view. So I've mentioned a few times that we build these identity graphs. Oh, just one comment. I am unfortunately working on one screen here, so it's a little bit difficult for me to see comments in the chat. So if you have any questions, please do post them into the comments section. One of my co-founders is there, and he will answer. I can see there's a question from Franz. And if Stefan doesn't answer them, I'll get to them at the end. This is an example of an identity graph. So I've used that term a couple of times, but an identity graph basically means all the data about one person represented in one kind of structure, which is connected together. So each of these dots is what we would call a node. It represents a data record, and they have been connected to other data records. So each of these records is a separate record in Companies House about this person that we have connected together. The lines are called edges, and they are the connections between the data records. So this record here, you can see is connected to, it looks like almost everything is connected to everything else here. But you could have, for example, one record here. Actually, it looks like, okay, this entity gets a bit bigger. So this record here, for example, is connected to this record here. And this record here is connected to this record here. But this record on the right-hand side is not connected to the one on the left-hand side. But being connected via this one, and I'll explain this one in a second, means that you have all the data about this person in this one visualization. Now, this kind of mess in the middle is what we would call a deduplicated node. And that is where the data here is more or less identical. But rather than form lots of connections with this data, we deduplicate it to make it more efficient for searching. It's too much detail to go into for this webinar, but every single gray dot here represents a deduplicated company record. You can see the same here. So there are a lot of companies associated with this person. Now, here we have the data view. And actually what we can see is we've got 4 separate results here. So that could be because there are 4 separate people with the same name, 4 separate Lucy Ann Whitfields. Or it could be that there is still some data that we were not able to match together. I suspect it's the latter. But you can see, for example, this one is a single record. So this one is, again, Lucy Ann Whitfield. We've got her date of birth. We've got the company she's associated with. We've got her occupation. There's lots more data, but I'm just not showing it all. But that record is on its own. If I go to the first record, that represents 3 companies that she is associated with. I'm pretty sure this one should be connected into the other ones. If I look here, I will see that she's got these 3 companies associated with herself. That looks interesting. I don't know what they are, but I'm just going to quickly show you the data view, because what we do is each entity that is created from all this data which is connected together has a ID. This is a persistent ID, which is unique to that entity as it's created. But all the data that made up this entity or identity is still there as well. So all these individual records have got an ID themselves. All the data about that record is in there. And this is only a subset of the data which is available. So we can see here, this is the smaller version of this lady. There is, let's look at a more interesting one. All right, so here is what we call edges. So here's the duplicates where the data has been optimized, and the edges are what I said is the connections between 2 records. So you can see here, this is an ID of one record, which is connected to this record, and we can see the rule which was triggered to connect the data. I'll talk about the rules in a second, but basically what this means is this is a fully explainable system. For any connection between one record and another, you will see the rule which was triggered to make that connection. So we'll get to that in a second, but before we do that, I just want to look at the big data set. So we're back to our big one. And if I click on the record insights, this shows us a kind of summary of all the data. So here's all the dates that she was appointed on to these companies. So make of this what you will, but on the 30th of April 2016, this lady was appointed a director of 429 companies. That sounds like a busy day. It looks like she had a lot of busy days. There you go. If I scroll down here, she's a very busy project manager, apparently. Interesting. Now, in this case, she's actually resigned from most or all of these. I should say about the data set, it's based on live companies. So anybody that's been a director of a live company is in this data set that we have here. What we don't have is dissolved companies. So my UK companies are all dissolved, long gone. So my data isn't by default in here. We added it manually just for the sake of showing it off. Now, if I look down at the companies that this lady was a director of, it's pretty interesting because it all looks like hotels, but not just hotels. It's individual rooms within a hotel, individual apartments, individual rooms. And obviously there are hundreds or thousands of them here. And I'm not from the hotel industry, so I don't know if this is normal to register a limited company for each hotel room, but there you go. That is what she has done. Now, this is just one of the interesting examples that I thought was worth looking at. There's lots more unique or interesting examples of company directors in there. And some of them, we're not the first person to find them. Perhaps the most famous is a woman called Barbara Cahan, who was apparently the director of up to 60,000 companies at one point. She was also, would be by now, well over 90 years old, and she lived in a relatively innocuous address in North London. But there was some suggestions that was not entirely straightforward, shall we say, the reason that she was registered to so many companies, because if you actually calculated it, she would, if she was to do an AGM for each one of those companies each year, she would only have like 2 minutes if she worked every single working hour and never took a holiday. So yeah, interesting. Certainly some interesting data in there. And if you search the name Barbara Cahan, it's been published. People had written reports about it or newspaper articles about it already. Just kind of an example of the sort of interesting data you'll see in there. So I just want to quickly show you what this looks like in Tilores. So this is our main dashboard. We ingested 18 million records about the directors. So there's not actually, or there's more than one record per director for various reasons. But the 18 million records was equivalent to the 10.6 or so million directors, and that resulted in 9.9 million entities we mentioned. Tilores is a completely kind of data agnostic system. It will match any sort of data. Here is the data schema of all of the company's house data. If you're not a data scientist or data engineers, maybe it isn't so interesting to you, but basically this is the structure of the database that we were looking at. And then the whole thing is based on rules. So if any individual rule is triggered, then two records would be linked together by that edge. And as you saw, you would then see the explanation of why that data was linked together. I recall that most of the matches were this one. So similar name and exact date of birth, but other rules would be something like similar name, exact postal code and exact birth year. So that's not looking at the month of birth. And yeah, any one of these rules was triggered would trigger a linking of the data. We have separate rules for searching the data, and then we also have the deduplication rules. So here you see the configuration that's used to set up Tilores linking. If these rules, any of those rules are triggered, so it's an OR system, any one rule is triggered, it'll be connected, searching, etc., etc. The matchers are the things that use the so-called fuzzy matching algorithms in them to do the matching. So these are all the different matchers which were used in this setup. So it's relatively complicated. If I look at here, a similar forename in the same order, then this is looking at what's called dynamic distance, which basically means how much difference is there between two names. So what we're looking for is when a name has like one extra character or one difference in it. So you might have Stephen versus Steve would be quite similar. If I look at the the text comparison here we see some of the algorithms which are used. The dynamic distance one, as I mentioned, is compared using an algorithm called Levenstein distance to compare how similar two bits of text are to see are they actually the same text. Metaphone is a phonetic algorithm, so if two words are the same phonetically but written differently, for example, Stephen with a V versus Stephen with a PH, then they would match. Another important thing in this whole process is what we call data transformation. So the data needs to be cleaned up a little bit before it's used in the identity resolution, and this is what this section does. So it's doing things like stripping out spaces, stripping out numbers from names, removing diacritical characters. That's a fancy way of saying strange characters or non-standard English characters. Removing titles from names, etc., etc. Anything we can do to make the matching more predictive, and then basically we pump the data into Tilores, and the matching all happens pretty much in real time. So that's all I wanted to show you about Tilores, just the one example, how the matching works. For those of you who are interested, the data ingestion normally happens via API. So you can be streaming as much data in here, whether it's 5 records a second or 5,000 records a second, you can stream it into here, and we will match this data in real time for you. So that brings me to think about where else might we find duplicate data. The company's house one is kind of an obvious one because you, for good reason, you can make you can register companies in the UK very simply. The challenge is that there is no identity verification when you create a company. So the data is known to be quite questionable. Companies House states itself they don't check the accuracy of the data. That's going to change. The Companies House, there's been, what would you say, legislation passed to improve the quality of the data in Companies House, and you will have to submit some kind of identity verification when you register a company in the future at Companies House, which will have a massive impact on the duplicate rate. There will still be duplicates, no question. We see plenty of companies that do identity verification and still have duplicates. And of course, the question is what you do with all the historical data. That's something we could help with. We were limited in how well we could match the data by what we can see in the public data. Of course, Companies House itself has the raw data. The raw data includes, for example, the exact date of birth. It includes the hidden, I think it includes the address of the directors when they don't want the address to be shown. So if we were to run Tilores within Companies House itself, i.e. the Companies House were to use it, they would have an extremely high matching rate and would be able to sort their data to a much better standard than we have been able to do for this showcase. Nevertheless, I'm interested in where we can look for duplicate data. I can imagine in the DVLA, which create the driving records for the UK. You could have people creating multiple records if they're being banned and they're trying to register again. HMRC is a very interesting one because entity resolution or identity resolution is a key tool for tax offices to understand the perhaps hidden relationship between people submitting their tax information. So it's not just about finding duplicates, it's about finding these relationships between people. And that's where I think HMRC data could be interesting. Health services have a massive issue with messy data because your data is quite often siloed. You have a data set at the hospital or a specific clinic, and then you have another data set at the GP, and it can be difficult to unify that data across different clinics, etc. This is particularly a problem in the US. I know that from speaking to many kind of insurance providers and healthcare providers there, that duplicate data is a nightmare, and it becomes critical because you can't get a patient's full medical history in one place. And of course, it causes problems for the insurance companies when it comes to charging for services there. And I would imagine there's a lot of duplicates in the electoral register. There's when people move house or they don't update their details, people will be left behind in the electoral register. So there's a good chance that that would be another interesting data set to work on. Of course, these are not data sets that we can work on because they're not public. But what could be interesting is to use Tilores on each of those institutions internally. But then you can also potentially use Tilores at the top level to actually compare data across all these different units. That's essentially what identity resolution is for connecting data across data silos. So just some thoughts that we have. Let's see if anyone wants to try it. Just quickly on our background, Tilores was built for a German consumer credit bureau where I was the chief product officer. And my co-founders were also from the credit bureau. They were the previous CTO at the credit bureau, Hendrik, and Stefan invented the technology. He is been working in the field of entity resolution for 10 years. He's really quite an entity resolution expert and is basically the brains behind our technology. He is in the webinar answering questions, I think. So if you have any technical questions, you can post them and I will try, or perhaps Stefan will answer them. But otherwise, yeah, I hope you found this interesting. This isn't something that we plan to turn into a service. We don't plan to offer the company's house data as a service. We could offer it via API, but we're not a data provider. We are a technology provider. So if other people want to use our technology to sort out company's house data that they're using, or for any other sort of data, of course, that's something we're happy to talk about. And yeah, I'd be very happy for anyone to get in touch later and talk about identity resolution and data deduplication use cases. I will now take a look at the, okay. So just looking at the questions. So yeah, integrations. Yes, technically we can integrate with anything. We have access to a whole bunch of easy integrators. So we can integrate into any sort of CRM service. Yeah, and as Stefan said, we did exclude the dissolved companies. That's because the initial download that you get straight away from Companies House only includes the live companies. You can get the dissolved companies as well. We just didn't do that for this use case. Of course, if you were using Tilores yourself, you could easily do that. Yeah, any more questions from anybody in the chat? Feel free just to type them in and we'll see what we can discuss. If not, then thank you very much for attending. If you do have any more questions, then feel free to contact me directly. Always happy to discuss this. We're very passionate about improving data quality. We think this is important, not just for government, but across industry. So thanks very much for attending. And yeah, that's all for now. Bye now.